My name is Dan Frechette. I'm a global black belt in IoT security with Microsoft Systems. What I'd like to be able to show you today is one of the aspects of the Defender for IoT platform that is rather unique and very, very powerful. As discussed in other modules, the Defender for IoT platform passively learns the environment that it's in and learns about the devices that are on them and their communication parameters. Now, with this information, we can do a lot of very interesting things. If I was to zoom in on this map, where each one of these dots represents an asset, I not only see the information on the asset, but I also see who it talks to in the parameters around that. Now, with this information, I can go in and look at details for this particular device. So if I was to go in and look at this, I can see it is a device made by Rockwell Automation. It's a PLC. It has a backplane. If I was to look into the backplane, I can see the model and version number. So if you think what we're doing, I know the manufacturer, model, and version, and I also know everyone it talks to and everyone that it talks to and who they talk to. And with this information, I can simulate an attack to these particular devices. So I can simply go in and say, I want to simulate an attack. This is what we call an attack vector. Now, very simple. It will go in and I give it a name and I give it the number of vectors it can possibly use. And we'll just say 20. I'm going to give it 20 chances to be able to get into one of these devices, and that's what I'm going to do here. So from any source that we've discovered to that device, I'm going to simulate an attack. Now, this isn't an attack that happened. This is a possibility. So it will go in and it will look at the database and the devices and their communication parameters and their version, and we can simulate an attack to that particular device. Now, it's going to list it out by highest to lowest probability, highest being at top, and here it's going to come up and tell us, okay, if someone was to come in and take control or try to compromise this particular asset, and because we know in this case it's a Rockwell Automation 1756, it has this CDE that it is susceptible to. With that information, I can say if an attacker was to be able to connect to this device from the internet, because there's an internet connection there, they can easily make their way onto this device and exploit this vulnerability. Now, with this information, I can harden my system. Now, in OT environments, updating the firmware for this particular device may not be something that people want to do immediately. It's something that has to be sandboxed and make sure that it doesn't impact anything else in that particular process. So the next best thing would be able to is break that internet connection. Build a firewall rule that prevents this device from talking to the internet or this device talking to this PLC. Now, if that's not possible, let's go and use this information to be able to curtail who this talks to out on the internet. Make sure that any internet connection is required and as narrow focused as possible. The idea is to be able to secure the devices within the OT environment. One of the best ways is to go in and check the internet connections that may be in this what's supposed to be an air-gapped environment. Now, as I go down these, you'll see that it's other avenues. It's still that internet connection, but if I go and look at this, this is an internal threat. This workstation can access this device because it has that vulnerability. I can also go in and look at this one. There's multiple CVEs, multiple devices along the way here. And here's another one, an inside workstation, because it has remote access capabilities to this device, which in turn has remote capabilities to this device, it can get back down to that same PLC we mentioned before, and because of its make and model, we know the CVE that it is associated with it. Now, another thing that you can do is do an any-to-any So instead of focusing on one, go and say, okay, from any device in my network to any device in my network, what are probable paths of attack? And as you can see, that internet connection one I mentioned earlier is available. But if I go down to some of these, we'll see stuff like that SSH connection, but stuff as rudimentary as plain text passwords that are being used. Now, this device is using a plain text password to talk to this device. It's SNMP. We actually can see what the password is because it's in plain text. It begins with P. There's a really good probability because of the protocol and what it begins with that the password for this happens to be public because that's a default SNMP community string password combination. So another way of hardening the system is to be able to go in there and change these plain text passwords to something that's a little bit more difficult to guess. Thank you very much for your attention.